Captain America is one of the world's famous Avengers. He's beloved by many and has a shield composed of metals that are unheard of. This shield is made of 2 metals and a special alloy. A majority of it is comprised of a metal known as vibranium and smaller amounts of American steel and a substance known as adamantium. However, in order to understand why Captain America can so easily throw his shield around in the movies, we have to take a look at small information of vibranium and adamantium. Vibranium is a substance that originates from a land known as Wakanda. Originally, the vibranium came from a meteorite that crashed into the nation's land. For the people of Wakanda, it served as a great push for a better economic system and a way to live. For Captain America, its purpose was to stop bullets and absorb high-energy beams from a cube known as the Tesseract. In the movie, Howard Stark has been noted saying, "It's stronger than steel and a third of its weight. It's completely vibration absorbent." Adamantium, however, is heavily associated with a mutant superhero known as Wolverine. This substance is man-made in a laboratory by 3 compounds that are closely related to iron. Adamantium, now in this case, is a classified substance under America's government and its component secret. The only reason why Captain America's shield is able to be so indestructible is due to the process of a chemical accident created by the scientists working on the alloy. This accident created a process called proto-adamantium, in which it created a rounded specimen when fused with vibranium. It hasn't been recreated since. There are many action scenes in Captain America. One of those action scenes happened to involve free falling. Now, free falling is associated with the pull of gravity. In each of these clips, there have been scenes of free falling and either hitting something before they reach terminal velocity, or they reach terminal velocity before landing in water or in rubble. Falcon and Captain America are free falling. What speed do they reach before achieving terminal velocity? I use the acceleration formula. This formula uses the weight of a person or an object in newtons as well as being divided by its mass in kilograms. This should get you meters per second squared. In my newton section, I put down 800.2 newtons for the weight of Falcon, divided by his kilogram weight, which is 81.6 kilograms. I then moved over and put down 800.2 kilograms multiplied by meters per second squared, divided by 81.6 kilograms. I then canceled out the kilograms, divided 800.2 kilograms by 81.6, and got 9.8 meters per second squared as my final answer. I then repeat the same process for Captain America. Instead of having the same numbers as they are different people and different weights, I put down 889.5 newtons divided by 90.7 kilograms. I then repeat the same process further by moving it over and putting down 889.5 kilograms times meters per second squared divided by 90.7 kilograms. The kilograms cancel out as they divide each other, and I am left with 9.8 meters per second squared. One of Captain America's most famous attributes throughout his movies is his shield throwing. Now, we know a lot about his shield already, as it is made of adamantium and vibranium. However, is it really possible that he could throw his shield at such a high speed as it's seen in? Well, I have done the physics, and yes, it is possible. Let's say Captain America is traveling at 3 meters per second and he throws his shield at 2 meters per second. Keep in mind that he weighs 90.7 kilograms and his shield weighs 5.4 kilograms. In order to get the speed at which the shield is traveling away from Captain America after he throws it, I must use an acceleration formula. This formula uses the velocity and mass of before as well as the velocity and mass of after. In the first mass, I use Captain America's kilogram weight, and then in velocity number 1, I put in a fake number, like 3 meters per second, as a representation of when he throws his shield. In the second mass, I put down the shield's mass of 5.4 kilograms, and then I added in the second velocity of what he might have thrown it at. On the other side, I added the two masses together. I multiplied the first mass with its velocity, and then I took the second mass and multiplied that with its velocity before adding the two together. On the other side, I added the two masses together and I left the velocity alone. The kilograms on the left side were divided by the kilograms from the right side, which gave me 2.91 meters per second. That was the rate at which Captain America threw his shield and it flew away. After re-watching the first two Captain America movies, Captain America First Avenger and Captain America Civil War, I have come to the conclusion that the Marvel Cinematic Universe uses real physics. Out of all of these movies, Captain America uses the most physics in my opinion. Because of this, it was easy to calculate the rate of speed at which he throws his shield, as well as when he falls into water or onto ground. Because of this, it was easy for me to conclude that yes, physics are used in these movies, and that yes, it is possible for these things to happen.